DC motor. Now let us we have to derive the torque equation of a DC motor, which is one of the very important questions, and it is also called as a gross torque or total armature torque, represented by the symbol TA, where A represents armature torque, that is total armature torque or gross torque. Now before going to derive the equation, let us know the definition of torque, that is what do you mean by a torque. A torque is defined as the turning force or twisting moment about an axis. That is, the definition of torque is nothing but it is the turning force or twisting moment about an axis. We can also call this as rotational force, and it is given by the product of force and radius. That is, torque is given by the product of radius and force, that is force and radius at which it is acting. So in order to give the equation of torque, let F be the force in Newton and R be the radius in meter. So therefore torque is equal to the product, that is product of force and radius, F into R in Newton meter. That is Newton meter is the SI unit for torque, that is force is the product of torque is the product of force and radius in Newton meter, and let us call this as equation 1. Now let us derive the equation for this torque. In order to derive the equation of torque, we have considered figure 1, where figure 1 represents the armature of a DC motor, and R represents the radius of this armature, and F represents the force, that is it is a tangential force which is acting along the direction of the rotation. That is force, F is the force and R is the radius of the armature of a DC motor. Now we need to calculate the work done in one revolution. That is, what is the work done by the armature in making one revolution, which is given by the product of force and distance covered in one revolution. That is, distance covered by the armature in one revolution, which is represented as W is equal to F into 2 pi R, where F is nothing but the force and 2 pi R is nothing but the distance covered or the distance travelled by the armature, because we have considered a circular armature of a DC motor. Therefore circumference of the circle, which is given by 2 pi R, is considered as the distance covered by the armature in making one revolution. And we know that the product of force and radius, that is F into R, is nothing but torque T. Therefore making the equation as 2 pi into T, that is F into R is nothing but torque T. Therefore it is 2 pi into T. The unit is joules, and call this as equation 2. Now we have to calculate total work done in 1 minute. Before we have calculated work done in one revolution, and now we are calculating work done in 1 minute. Therefore work done by that armature in 1 minute is given by W is equal to 2 pi N into T. That is, multiplying equation 2 with N, where N is nothing but speed of rotation in RPM, where RPM is nothing but revolutions per minute. As we are calculating work done in 1 minute, we have considering N, that is speed of rotation in RPM, that is 2 pi N into T joules per minute, and call this as equation 3. And now we are calculating total work done in 1 second. That is, we have calculated total work done in 1 minute, and now we are calculating work done in 1 second. Therefore, dividing equation 3, that is equation 3 is in work done in minutes, that is joules per minute, and we are converting this equation to work done, that is joules per second. Therefore, dividing equation 3 by 60, where 60 is nothing but number of seconds in a minute. Therefore W is equal to 2 pi T N by 60, where N by 60 is nothing but revolutions per second. Therefore the equation becomes joules per second. Now we are calling this as equation 4. And now we are calculating TA, where TA is nothing but the total armature torque or the gross torque. If TA is the armature torque developed and N is the speed of rotation of the armature, then the electrical power is equivalent to the mechanical power developed by the armature. That is, the concept is, as we know that the basic working principle of a DC motor, that is, the basic working principle of a DC motor is to convert electrical energy into mechanical energy. That is, the basic working principle of a DC motor is to convert electrical energy into mechanical energy, which is nothing but electrical energy is given as input and mechanical energy is taken at the output side. Therefore, what we have to do is, the input which we are given in the form of electrical energy, and we need to obtain the same amount of mechanical power at the output side. Therefore, taking this concept, mechanical power developed, that is represented as Pm, which is equal to the product of torque and angular velocity omega, where omega is equal to angular velocity. Mechanical power developed is the product of torque and angular velocity. Therefore, Pm is equal to torque, and here we are taking total armature torque, therefore representing T as TA, that is total armature torque TA, multiplied by angular velocity is nothing but 2 pi n, that is 2 pi n is nothing but omega joules per minute. I am calling this as equation 5. And now the final equation for mechanical power developed by the armature is equal to Pm is equal to TA into 2 pi n by 60. That is converting revolutions per minute to revolutions per second. That is same thing, joules per minute to joules per second. Dividing equation 5 by number of seconds, that is 60, will get joules per second, and calling that as equation 6. And we know that the electrical power input, that is input is electrical power, output is mechanical power developed. Therefore, electrical power input, which is represented by the symbol P, is equal to EB into IA, where EB is nothing but back EMF, that is back EMF of a DC motor, and IA is nothing but the total armature current. That is, input is nothing but the electrical power, which is equal to the product of back EMF EB and total armature current IA. And now we know that there should be always, the condition satisfied is input should be always equal to output. We know that the output obtained should be always equal to the input given to that system. Therefore, taking this concept, equating equation 6 and 7. Equation 6 is nothing but the mechanical power, and equation 7 is nothing but the electrical power. Mechanical power should be equal to the electrical power, that is nothing but Pm should be equal to Pe. Electrical power should be equal to mechanical power. Therefore, mechanical power is nothing but TA 2 pi n by 60, that is, which we have given as equation 6, and electrical power is nothing but equation 7, that is EB into IA. EB into IA. On equating equation 6 and 7, and by solving equation, that is, we know that the equation for back EMF EB is equal to 5ZNP divided by 60. This is the back EMF equation of a DC motor, which we have already derived. Therefore, taking this EB, that is back EMF equation, as 5ZNP divided by 60A into armature current IA, and solving these two equations, that is mechanical power and electrical power, and simplifying the equation to get the total armature torque TA, will get the equation as 1 by 2 pi 5ZIA P by A in Newton meter. That is the standard unit of torque. Our total armature torque is nothing but Newton meter. And we can also solve this equation, that is, we can solve this equation in order to get the numerical values for 1 by 2 pi. We'll get the next equation, that is equation 8. That is, the value of 1 by 2 pi is nothing but TA is equal to 0.1595 ZIA P by A Newton meters. That is, the value of 1 by 2 pi is nothing but 0.159, and we'll get the equation 8. And in order to convert this equation, that is the divide the equation 8, that is equation 8 should be divided by 9.81. Equation 8 should be divided by 9.81 in order to get the equation 9, that is equation 9, which is the torque equation in terms of kg meter, that is dividing 0.159 divided by 9.81, which will give us 0.0162. On dividing 0.159 divided by 9.81, we will get 0.0162. Therefore, the total armature torque is equal to 0.01625 Ia into P by A in terms of kg meter. I am calling this as equation 9. That is, equation 8 and equation 9 represents the final equations of total armature torques in terms of Newton meter and in terms of kg meter respectively. Derivation of torque equation or total torque equation, total armature torque equation, or you can also call this as gross torque equation.